Hi everyone, I am Dr. Bhartivi from Department of Computer Science PG, Kristu Jayanti College. And today we are going to discuss about the computer vision topics, a few computer vision topics where we are going to discuss on the image enhancement, image analysis, image segmentation, image restoration, and image compression. So here, the first is the image enhancement techniques. The image enhancement techniques is so when you want to enhance the characteristics of the images, say for example, you have an image with the sharpness is very high or the blunt is very high, you can change the characteristics of the image, which all denotes the image enhancement. Here, for example, you can include the contrast and edge enhancements, the pseudo coloring, noise filtering, shortening the image, so which all comes under the image enhancement techniques. So here the image enhancement process itself does not increase the information content, whereas it emphasizes certain characteristics of the images. So it has got a lot of algorithms, the image algorithm techniques, which is applicable for the image enhancement. There are three main techniques for the image enhancement techniques. So the contrast scheduling, noise filtering, and the histogram modification. So what is contrast scheduling? So for example, we have a certain images in the dense forest, snows, clouds. So in those conditions, you cannot able to find out what is what. So you have to enhance the images, either increasing or decreasing the contrast or sharpness or the edges, the clarity of the edges to achieve the precise clarity of the edges. We have to enhance the characteristics of the image. So the first method, which is contrast stretching, which is means like, so it has been developed to stretch the narrow range to the whole of the available dynamic range. So that is what main is the contrast stretching. So, and it also exists only a narrow range of gray levels in the image, having provision for a wide range of the gray levels. So sometimes the homogeneity can also due to the incurrent illumination of the scene. And this is going to be the one of the methods of the image enhancement. And second one, if you could look at the example which has been shown, so the contrast stitching provides a better clarity than the original image. Second one is going to be the noise filtering, where here noise filtering is used to unfilter the information from the images. So it is used to remove various types of noises. So for example, we have a noises that also determines the characteristics of an image, the sharp, the blunt, and of course the color. So all those things which comes under the noise filtering. So we have various filters like low pass, high pass, mean, median, and which is available in the noise filtering. So a sample pictures has been shown where the original picture and after noise removed of the original picture, how the clarity is being provided. And third category which comes under the image enhancement is histogram modification, where you have a lot of importance in image enhancement. And this is the one which is a non-linear stitch. So which uniformly distributes the pixel values across for the entire picture. So it is a flat histogram. So therefore the contrast is increased at the peaks and lesser at the tiles. So and most of this by modifying the histogram, the image characteristics can be modified. And the example we can see for the histogram example. And next one is going to be the image analysis. So image analysis is the process of extracting meaningful data. So what sort of data is in the picture? So analyzing that which has got a lot of computer vision use cases from the image analysis, and which tasks, there are certain tasks such as statistical analysis and property measurement. And the main criteria in image analysis, segmentation. So here to do a analysis in the image, first step is to segment the images. So for example, we need to identify a particular car in a traffic signal image. So we have to identify the segmentation is going to be which signals image. And after identifying the signal, we have to identify the car segment. And after identifying the car segment, we have to identify the car's number segment. So once it is at reach to the root of the requirement, then we can stop the segmentation. We have a lot of algorithms in the image segmentation, both automated and the semi-automated. The automated algorithms is going to be segment and anything model and k-means clustering methods, whereas semi-automated algorithms such as graph-based and active control techniques. So the rest of the topics we can discuss in the next session. Thank you.